Hello everyone, this is a brief demo of the new version of RARecom, the Resource Adaptation Recommender, which is part of the work done in the PrEstoCloud project. In order to provide a demo of the work done, we have created a simulation which will allow us to visualize how the recommendations, the resource adaptation recommendations sent by RARecom can affect a system. Furthermore, we want to focus on the feedback service, which basically improves the resource adaptation recommendations which are sent by analyzing recommendations sent in the past and the current topology of the system. And before starting, let me give you a brief introduction of how we're going to set this up in order for it to be understandable to the user. Initially, this is our UI configuration. This is done in user space, so this is something that the DevOps or sysadmin will provide. We have two rules which are simple enough. The first just says if the CPU is greater than 80% and the memory is greater than 60%, then perform a scale out, which means increase the instances. And if we have the CPU less than 40% and the memory less than 30%, then scale down, which means decrease the instances. Now, for the purpose of this demo, an instance is considered as one CPU and 2 gigabytes of memory. So every time there's going to be an increase or a decrease of instances, those two numbers are going to be affected. Using this UI configuration, the situation detection mechanism creates the necessary rules in order to detect situations in severity zones. So the number of instances that are going to be sent as adaptation will depend on the severity zone where a specific situation falls on. Before moving on, I would like to go over what severity zones are. Each dot in this graph represents a situation. We have computed a distance. We have a formula which computes a distance value in this graph, and it is composed of all the metrics in which a situation is affected on. For example, in our configuration, in our scalability rules, we have both the CPU and the memory. So we use those two values to compute the distance and see under which zone the specific situation falls under. And depending on the zone it falls under, then the number of instances that need to be increased or decreased is directly correlated. This is really important because the feedback service acts on these severity zones and changes the specific rules for the specific zone. And we're going to see all this in the demo. Here is a simple Grafana dashboard. Okay, let me start RARecom. I would like to note that the reason you're seeing the CPU load above 100% or the memory load above 100% throughout the demo is due to the fact that this shows the projected load of the system in order to be able to visualize that a situation has been detected and the topology has been adapted accordingly. Now, once I start the simulation, we're going to start simulating workloads into the system. The correlation between a workload and the CPU, I'm not going to go into detail in the demo. However, you can read the code. It's available online in the project's repository. For the simulation purposes, and in order for us to better visualize what's going on, we're working with a very slow CPU. Sorry, with a very slow load, which occurs once every 5 seconds. And that's because Grafana doesn't allow a better refresh rate. Anyways, let's start the simulation. Once we start the simulation, workload data points are being sent into the system, and RARecom starts working right away. Different situations are being detected by the situation detection mechanism. And if you give it 1 second, Okay, so here we got our first situation where the CPU and the memory is over 100%. Therefore, this falls into the severity zone 3. And for the purposes of this demo, when you are in the severity zone 3, you're asked to do a scale out for 3 instances, as you can see here. So this is RARecom picking up the situation, and this is the simulator getting the action sent by RARecom and performing the change in the topology. Then, in order for us to show the effects of the feedback service, we've created an extreme workload situation so that you can see how recommendations are being improved. In this scenario, we can see that we get a second situation detection, which says you're still at 100% for memory and CPU. You need to do something about it. So again, the RARecom sends a new scale out topology event, which says, please scale out by 3 instances. Now, in this situation, it's interesting because the RARecom configuration at this point tells us that once you hit a second situation within a very short amount of time, then you should improve that rule for that severity zone. And so we can see here, we're improving that rule, and we're saying that the next time that you hit the severity zone 3, you should increase your instances by 4. And this is exactly what happened, because due to our scenario where we purposely have the workload working at like 500, 400%, in order for us to show you the feedback service, you can see that the next scale out that was matched asked us to increase our instances by 4. And if you compute like the CPU and the memory, you'll see that it's 3 plus 3 plus 4. Furthermore, there's another interesting situation occurring here, which I want to show you. Once we're able to scale our system and get it under severity zone 3, that doesn't mean that the RARecom stops working. As we can see here, once our system has gone under 100%, however, it's still within the areas that have been defined as severity zones, we're also hitting severity zone 2. Therefore, we're being asked to increase our instances by 2. And once we've increased our instances by 2, then we're also hitting severity zone 1 and getting our instances increased by 1. Therefore, as you can see, it's a system that is trying to get as close as possible. The feedback service, along with RARecom, is trying to get the topology as close as possible or as efficient as possible to that which is necessary for the workload that's there, that was there, and that is going to come in the future. I'm going to let the system run for a while and just show you something else that's going to be really interesting, which occurs once the workload falls. So we also have the scale in which case RARecom and the feedback service improves how the system is going to scale in, so how the instances are going to be decreased. So if we let it run for a while, for 2 seconds, here's a good example of how our current topology is way too much for our current workload. Therefore, the RARecom correctly sends us a scale in, and since that scale in is not going to be enough, we're going to get a second adaptation, given that we're still falling within the severity zone 1 of the scale in. Okay, so this is the end of the demo. As you can see, this is basically what we're trying to achieve: keep the load as close as possible to 1, and then trying to improve the recommendations, whether it's scale out and scale in. The code is available on GitLab, so you're able to just check it out and run it. They're Gradle projects. And thank you.